All right, number 49's answer for vertical asymptote is x equals 1, and I got that by setting the denominator equal to 0. The horizontal is y equals negative 1, and I got that by finding the limit. Our y-intercept is 0, 2. I got that by putting 0 in for x. Our x-intercept is negative 2, 0. I got that by putting 0 in for y. And I found that there were no critical numbers, and technically you should talk about x equals 1, but it's not a critical number because we already stated it was a vertical asymptote, but something is going on there. And there is the graph. Number 50, I said x equals 2, vertical asymptote, y equals 1, horizontal asymptote, y-intercept 0 and 1.5, x-intercept 3, 0, no critical numbers. And there is the graph. Number 51, I got a vertical asymptote at 2 and negative 2, because when you unsquare 4, you get two numbers. A horizontal asymptote at y equals 0, x and y-intercept at 0, 0, no critical numbers, and there is the graph. For number 52, I got a vertical asymptote at x equals 3 and x equals negative 3. A horizontal asymptote at y equals 0. X and y-intercept are both 0, 0, and there's your graph. No critical numbers. For 53, I got y equals 1 as a horizontal asymptote and 0, 0. 54, horizontal asymptote, y equals 1. Vertical asymptotes at x equals 3 and x equals negative 3. 0, 0 is your intercept, and there's your graph. 55, horizontal asymptote at y equals 2. Vertical at x equals 2 and x equals negative 2. 0, 0 is your intercept, and there's your graph. 56, a horizontal asymptote at y equals 2. 0, 0 is your intercept. 61, vertical asymptote at x equals 0. Horizontal at y equals 2. Y-intercept does not exist. X-intercepts are at 1.220 and negative 1.220. There are no critical numbers, and there's your graph. 62, you have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 1. There is no y-intercept. Your x-intercept is negative 1, 0, and no critical numbers, and there is your graph. The next part of the chapter is dealing with long division and slant asymptotes. Sometimes we got a limit as x went to infinity, and we got our answer to be infinity, and so we said that there was no horizontal asymptote. Well, that might mean that there is a slant asymptote there. So to find out if we have a slant asymptote, we have to do long division. Now, slant asymptotes are like the dotted line that is up there, and they are y equals mx plus b, because they will have a slope, as opposed to the horizontal tangent of y equals y equals b in a horizontal asymptote. I don't know what I'm talking about. So y equals b is your horizontal asymptote, where y equals mx plus b is your slant asymptote. Notice the slant has a slope now. See you in class. Come ready to put x-intercepts, y-intercepts, horizontal asymptotes, vertical asymptotes, slant asymptotes, critical numbers, points of inflection, concavity, increasing and decreasing, all together.